Okay, hello everybody. Today we'll be learning about what a fluid is. So, from our memory, a fluid is anything that takes up space and could be divided between a gas and a liquid. So, what do we know about a liquid? We know a liquid is incompressible. No matter how much force you add onto it, you could never ever change the volume. While a gas, if you add enough pressure, you could actually change the volume, changing as a result, changing the density of the gas. So this accepts change in density. So change in density works for this, but change in density does not work for liquids. You could never ever change the density of a liquid. And then this is like you could theoretically, but you would need a lot of force. And then using this concept, let's move on to derive the equation we normally use in AP Physics B classes for fluids. So So if you have a fluid, right? If like if you have a fluid and the fluid is inside this container and this is the area A. If you apply a force here, if you apply a force here over this area, you just applied pressure, but pressure is not a vector though. And then what happens to the pressure inside of this liquid is that the pressure distributes equally among the liquid. So for every single cross-sectional area, for every small area, there's a force pointing out. Like for this small area, there's a force pointing out, and it's always perpendicular to the surface. It's always perpendicular to the area. Why? Because, if you think about it, if you have this box, right? If you have this box and there's a whole bunch of small holes in it, there's like a whole bunch of small holes, and then the small holes to say it doesn't affect the liquid from coming out. If you apply a force here, all the liquid that's inside of the container will squirt out from this. All of the liquid will squirt out from these small areas, and it will always point perpendicular to the surface. It will point perpendicular there, here, everywhere. It's gonna point perpendicular to the surface if you apply this force. Why? Because all of the pressure, when you apply this force, there's a pressure the pressure distributes equally among every single part of the liquid, and every single cross-sectional area there's a pressure pointing outward. That's how you could think about it conceptually. How, why, if you apply a force on a liquid, the pressure will distribute equally among the liquid. And using this concept, we could derive the equation of pressure 1 equals pressure 2 plus rho gh. So let's say we have a container, maybe like let's do it before. Say we have a container here, right? And this is made out of liquid, so blue for liquid, right? And then let's say you apply a force on it here. The liquid, all of the pressure would distribute equally among the liquid, and since the pressure would be pointing perpendicular to the surface at every single point, there'll be some pressure that would point up at this point. There'll be some pressure that points up. Just use a different color. Yeah, there's a force that acts that points up in this direction because of this cross-sectional area. because of this cross-sectional area. And if you consider gravity, you have the force of gravity pointing down, right? So since you have, and then let's consider this fluid to be perfectly static, and there's no component that's parallel to the box. Because if there was a component parallel to the box, the parallel component will make the fluid move to the right. And let's consider there's no parallel component of force acting on it. So that means we have static fluid, right? If you have static fluid, this pressure is called this pressure 1 must equal this pressure is called this pressure 2 and the pressure of gravity, because the object is in equilibrium, right? If we know this, we could write an equation for it. We could write that pressure 1 minus pressure 2 minus the pressure of gravity must equal 0. So, and we know that density equals mass divided by volume. And if you multiply density by volume, you get mass. So density times volume equals mass. And you know that volume equals area times height. So if you write density times area times height equal mass. Let's show you this. And show you something here. And just erase this. Help you remember it. And since we already know that mass equals density times area times height of the liquid, we could write that, and we also know that pressure equals force divided by area. We could write that the pressure of gravity equals mass times acceleration due to gravity, because it's the amount of weight that points down divided by the cross-sectional area of part of the container. And we know that the areas will cancel out, because this mass equals the density of the liquid times the area, the cross-sectional area, times the height. This height, I shouldn't call it height, it's just the distance displaced. So we get that these two areas, they cancel, and you end up with, if you rearrange this equation, you get that pressure 1 equals pressure 2 plus rho gh, which is the density of the liquid, times acceleration due to gravity times the height. And you're all familiar with these equations. Okay, and that's about it. Okay, see you in the next video, and I'll explain more about how this concept is used to like lift cars. It's called a hydraulic press, I think. And correct me if I made any mistake.